Good afternoon.
Good afternoon.
All right. So, anybody do anything amazing over the weekend?
We beat Baghdad.
How bad did you beat them?
It was 28-18.
Oh, okay. Oh, that's pretty cool. So now you play who next? Superior?
Yeah, we play them in the semis now. So.
Very cool. So is that this Friday?
Yeah, it's this Saturday.
Oh, this Saturday. All right.
Yeah.
So do you play at their place or yours?
No, we play in the Valley at Coronado. So.
Oh, okay. All right. Very cool. Well, good luck on that. Anybody else? Surely volleyball team's still alive, right?
Yeah, we're still going.
And who do you play next?
I don't know, but we're playing on Friday.
Matter. It doesn't matter. Is that what you're saying?
I mean, I just go with the flow. Wherever we play, then
She doesn't play.
I do. Yeah.
The microphone.
You'll just crush them. All right. Well, so did. So let's see. Winslow, did you guys have another band competition?
Yeah, we actually had state on Saturday, so we made the state, and then that was our last competition. But it was really great.
So how did you guys do?
We placed 18, so it was okay, but we didn't get any lower. So.
And did you get like the drum major of the year award?
I did not, but it was just an honor anyway. So.
All right. Well, that's cool. Well, that's
yeah.
great. Go ahead.
And then also, I meant to take that test on Friday, but it never opened up on my Moodle. I wanted to take it, and it said it wasn't open.
Which test?
The reattempt, the second attempt on the Chapter 3 test.
Okay.
So I never retook my second attempt because it wasn't open when I.
Okay. Well, because we need to get that done before the midterm. So, is there a time when you want me to open it up now?
You have to take yours too. When do you want to do that?
I can do it whenever.
So,
maybe
Skylar, then you need to do it as well?
Yeah.
Okay, so...
That works.
What time is that?
You want to do it today?
We can do it tomorrow. We can do it tomorrow at a... Let me look at the time. We're just trying to figure out what time the class starts.
Okay, all right.
8:25.
Yeah, I think so.
Chapter 3.
Oh, 9:25.
Test.
Can we do it at 9:25 tomorrow?
9:25, okay.
Or maybe 9:30 just to...
Okay, we'll do it 9:30. Okay, Chapter 3 test.
Okay.
All right, very good. All right, what else? Anything else going on?
We have a robotics competition this weekend. We're not.
What about your duck?
The duck is still being worked on. That's coming there, but we have a robotics competition, and we're not competing, but we're hosting it. So a bunch of other teams are going to be there.
Oh, that sounds cool. So now I can't remember. Is it First Robotics or Vex that you're part of?
First. FTC.
All right. Well, that should be fun. Well, I know I enjoyed. I think it was it last year or 2 years ago? Anyway, somebody sent me a video of their winning robot. Did you guys win last year or 2 years ago?
It's probably Jeremy.
Yeah, maybe so. And it seems like St. John's was involved in robotics too. Do you guys still have a robotics team in St. John's?
Not this year, no.
No. So anyway, well, well, Jordan, what day is your robotics competition?
It's Saturday, and it'll be a bunch of teams.
That's pretty cool. Well, so I hope it's not going to conflict with your playoff football game. You know, you should totally have the robots race at halftime or something like that. That would be kind of cool. Or have a battle of the bots or something. anyway. Or have like your slow robot like dress them up in like superior colors, and then have your other robot like beat it up or something. Anyway, just an idea. All right. Okay. So anything else? Anybody else do anything?
Mr. Strong, I have a joke for you.
All right. I would love to hear a joke.
All right. So there's a lady and she's working at a drive-thru at McDonald's. And so someone comes up to order and she says, "Hi, welcome to McDonald's. Can I take your McOrder?" And then her manager says, "Come on, lady. You don't have to say Mick in front of every single word that you said, in front of every word you say." And she says, Okay, fine. "Hi, welcome to Donald's. Can I take your order?"
All right, that's good. That's good. That is good. Well, I remember one time I asked somebody if they were going to get a McJob over the holidays. And anyway, that was pretty funny. And then I found out that McJob is actually a word now. So anyway, and it just means a job in the fast food industry. So if you get a McJob, then that's it. So anyway, all right. Well, so this week we're on the last problem, practice 4 on 4.2. We are also going to go on to 4.3. I'm also hoping that today or tomorrow maybe you have some questions for me to help you start thinking about the midterm. And then we will have the midterm during class time on Wednesday and Thursday. So I'm not going to have you do other tests or quizzes this week outside of class time, because basically on Wednesday I want you to be studying for the midterm. Okay, so I'm not going to pile up extra assessments for you to do. So it's just the midterm this week on Wednesday and Thursday, and then studying for it basically.
So if we didn't finish the quizzes from chapter 3, you don't want us to finish them?
I do want you to finish them.
Oh, okay.
I do want you to finish them. So, but I think they're still open, right? I think they're still open. So I do want you to finish those. Whatever you didn't get done over the weekend, I think it would be good. Well, I want you to finish those before the midterm. What I'm saying is that I'm not, you know how like every Wednesday I assign you to, you do stuff outside of class. Anyway, we're not doing that other than getting ready for the midterm and taking any of those quizzes. Okay. All right. Any other questions about this? What we're going to do this week? Okay. Now remember, if you do have an issue, if something pops up, then text me, email me, whatever, before the midterm if there's an issue. Okay. If it's after the midterm, you'll have a 0. Okay.
Mr. Strong.
Yes, sir.
I think I have to leave class like 5 minutes early tomorrow because I have an interview with a college.
Okay. All right. That's fine. No worries. Okay. Well, so before we finish up practice 4 on 4.2, does anyone have any other questions that we want to talk about before we get started? Okay. Well, let's go ahead and get your 4.2 out. We're on that last problem, practice 4. And this is actually a pretty important example as far as examples go, because this, down the line, we're going to do a lot more of this kind of stuff. So I want to make sure you understand this. So what we were doing is we started off with the acceleration function, and then we worked through the velocity function. And then I asked you to kind of finish it off and get the position function. Okay? So let's kind of remind ourselves what we did up to this point. So we were told that the acceleration was 9.8 meters per second squared. So since the object was free falling, we made it negative because it's heading toward the Earth. All right, so then we remember that the derivative of the velocity is the acceleration. So we were kind of thinking backwards here and saying, what function has for its derivative negative 9.8? And the answer was negative 9.8t plus some constant that we don't know. So we're just putting plus c there. All right. Then we use the initial condition, which says it's falling from rest, which means its initial velocity is 0. And so then you plug in 0 for t and 0 for v. And so then when you solve for c, you get c equals 0. And so the velocity equation was negative 9.8 t. Okay? So any questions up to that point? That's where we dropped off. All right, so now what we need to find is the position function. All right? So did anyone do that? Anyone find out the S equation? What equation would have this negative 9.8t for its derivative?
Maybe. So I didn't put in the negative anywhere, but I got 4.9 t squared.
Okay, so just put a negative in front.
Okay.
So negative 4.9 t squared plus some constant.
Would it be 100 because that's the initial?
Well, you're jumping ahead here, but we are going to find that constant. But so instead of saying plus c, we don't want to get it confused with that c. So what we do is just say plus c2. So it's negative 9.8 t squared divided by 2, which you're absolutely right. That ends up being negative 4.9. Oops. So negative 4.9 t squared plus c2. And so now we use the fact that the initial height is 100. Okay? So if the initial height is 100, then that means when t is 0, the position is 100. And so then when we solve that for c2 or whatever other variable you want to use, you could use k or something. But when we end up getting that second constant is 100. And so, Joey, you're absolutely right. That it ends up being negative s equals negative 4.9 t squared plus 100. And so that's the second answer there. Okay. Now, in general, when we're trying to figure out, when we're given the derivative and we're trying to figure out the original function, it's kind of like the shortcut is using like the power rule in reverse, where let's say if this is the derivative, then the original function, you add 1 to the exponent and then divide by that new power. And then plus a constant. And then see if you're ever not sure, then what you could do is take the derivative of this and see if you get what you started with. See if you take the derivative here, you bring the 3 in front, the 3 will cancel with this 3 down here, and then it's 1 lower power, and so you get x squared because the derivative of c, of any constant, is 0. It just goes away. Okay? All right. So, good job, Joey. Any other questions on that one? All right, so we'll come back to that. We'll come back to that idea later down the line. All right, so now we're going to go on to 4.3. which is called monotonic functions and the first derivative test. All right, so we start off with this word monotonic. Okay, all right. What does the prefix mono mean?
One.
One. Okay, and in terms of math and graphing and so on, monotonic means it's, well, for lack of a better word, like the rock group, the pop boy band One Direction. That's what it means. Monotonic is like One Direction. Okay, but don't start singing. Okay, anyway. So functions that go in one direction. So it says, let f be a function defined on an interval I, and let x1 and x2 be any 2 points. All right, so if the f of x1 is less than the f of x2, so that means the one y value is less than the next one. As your x's are increasing, then f is said to be increasing on I. So as you add in the next x value, 1, 2, 3, 4, if the y values keep going up, then the function is increasing. If the f of x2 is less than the f of x1, so that means the next y value is less than the previous one, then f is decreasing on I. And so a function that is increasing or decreasing on I is called monotonic. Okay? So it's just, okay. Okay, suppose that f is continuous on the closed interval, differentiable on the open interval. Okay, if f prime of x is greater than 0, so in other words, if the derivative is positive on every point, then the function is increasing on the interval. And if the derivative is less than 0 or negative at every point, then f is decreasing. So the way to tell whether a function is increasing or decreasing without looking at a graph is you look at the derivative. And you say, okay, where the derivative is positive, that means the function is increasing. It's going up from left to right. Where the derivative is negative, the function is decreasing from left to right. Okay, so to find out where the derivative is positive and negative, what we actually do is first find out where it changes from positive to negative. So that would be the critical points again. So remember, the critical points are where the derivative is 0 or undefined. Okay, so we found the critical points last time. And then we're going to use these critical points to find where the function is increasing or decreasing. And this is what's called the first derivative test. Okay? So, all right, so we start with the function. All right, so to find the critical points, we take the derivative. All right, now, there's no fraction here, so we don't have to worry about where the derivative is undefined. We just need to worry here about where the derivative is 0. So we take the derivative and set it equal to 0 and solve. And so here, divide by 3, take the square root, and so we get x equals plus or minus 2. So plus or minus 2 are the critical points. So it's the same way that we found the critical points when we were finding absolute max and mins. Okay? So take the derivative, set it equal to 0, and solve. All right, now, those two critical points, we graph them on a number line. Okay? All right. So what we do is we're going to make what we call a sign chart. All right? So here we've got plus or minus 2. And then you want to label your sign chart F prime. Because sometimes we'll do the sign chart for the function. Sometimes we'll do the sign chart for the first derivative. Sometimes we'll do the sign chart for the second derivative. So it is important that you label this F prime of x. Okay? You've got your numbers -2 and 2. All right, now you do sign charts when you're solving quadratic inequalities in Math 152. But just in case you don't remember that, let me show you what you do here. All right, what you do is you just pick any number in each region and check it and see if it's positive or negative when you plug into the first derivative. So you pick any number to the left of -2. Let's say -10. All right, you plug it into the derivative. -10 squared is 100, so 300 minus 12. We don't really care what the number is, we just care if it's positive or negative. So that's positive. All right, then you pick a number between -2 and 2. Now, if I can pick 0, I always pick 0 in whatever interval 0 is in. So you plug 0 into the derivative. So 0 squared times 3, that's 0 minus 12, that's negative. Finally, you pick a number to the right of 2. So let's say positive 10. So here we get 100 times 3, 300 minus 12, that's going to be positive. Okay? So any questions on the sign chart? All right, so now where the derivative is positive, that's where the function is increasing. Where the derivative is negative, that's where the function is decreasing. Okay? So you say that it's increasing from -infinity to -2, it's positive, and then from 2 to infinity, the derivative is positive. And then the function is decreasing from -2 to 2, as the derivative is negative there. All right? Any questions? All right, well, let's see if you can do practice 1. Okay, so looking at the graph of that example, see the function is going up from x equals negative infinity to x equals 2. So it's increasing. And then it's going down from negative 2 to positive 2. And then it's going up again from 2 to infinity. Okay? So a lot of times you can use your graph to sort of check your work on the first derivative test. All right, so Skylar, on what intervals is the function increasing and decreasing?
Decreasing from negative infinity to 0 and increasing from 0 to infinity.
That is correct. Okay. Now, I like to put it on as intervals, but you could also use inequalities there. And so when you do your sign chart, you get negative, and then the derivative is 0 at 0, and then positive. Okay? Any questions on that? Anyone need me to work through it? All right, great job. So the one that you just did, just looking at the graph, y equals x squared, see on this part the function's going down, so it's decreasing, so the derivative will be negative here. And then on this part of the graph, it's going up, so the function is increasing, the derivative would be positive here. Okay?
So at 0, would you just say that the derivative isn't changing at all?
No, actually the derivative would be 0 there. So that's your critical point. That's where the derivative is 0. Okay. So going back to what we did in 4.1, that's your absolute min at that point. Okay? All right. So now, okay, we did this same graph earlier when we talked about absolute maxes and mins. But now let me relate it to the derivative now. So here we have our absolute min, and then where the derivative is positive, the graph is going up. Where it levels off, you have a derivative is 0. Then it goes up again, so the derivative is positive. And then when you have a local max, the derivative is 0. Then it goes back down again, and when it's going down, the derivative is negative. The function is decreasing to right here, where you have a local min, the derivative will be 0 again. Now, as the function is increasing, the derivative is positive to this point right here where you have an absolute max. And because it's a corner point, the derivative is undefined. Now the function is going down, and so the derivative is negative. Here it levels off when the derivative is 0, and then the function is decreasing again, so the derivative would be negative to your local min is your endpoint. So we can use the first derivative to tell us a lot about how the graph should look. Okay? All right, so the first derivative test for local extrema. So again, this is kind of going back to the idea of where you have a max and a min. So suppose that C is a critical point of a continuous function f, and f is differentiable at every point in some interval containing C except possibly at C itself. So moving across the interval from left to right, if f prime changes from negative to positive at some point C, then f has a local minimum. Okay, so this is kind of a picture here for number 1. So the derivative is changing from negative to positive. And so then that makes this point here a local min. Number 2, if f prime changes from positive to negative at C, f has a local maximum. So this is the drawing for number 2. So the derivative is positive, 0, negative. So we have a local max. All right, number 3, if f prime does not change sign at C, that is, f prime is positive on both sides of C or negative on both sides, then f has no local extrema. So here, this would be an example for number 3, where the derivative would be negative, 0, and then negative again. So the sign didn't change of the derivative. So that means that point here in the middle is neither a maximum nor a minimum. All right. Okay, so now I'm going to use the first derivative test that I used in practice 1. And now not only am I going to find where the function is increasing or decreasing, but I'm going to use it to find the local max and mins. Okay, so I take the function, and the first thing I do is I'm going to take the derivative. So the derivative, I bring the 4/3 in front, x to 1 lower power, x to the 1/3, minus 4/3 x to 1 lower power to the negative 2/3. Okay? Now, this part you need to watch very carefully because I know you don't have a lot of experience factoring out rational exponents. So you might even want to write this one down. Okay? So you clearly have a 4/3 in each one of these. And then you have an x in each one. So you factor out the lowest power, which would be negative 2/3. So you factor out 4/3 x to the negative 2/3. And then you write down what you have left. Well, here you factor out the 4/3. So you have x to the... Well, you subtract your exponents. 1/3 minus the negative 2/3 is 1. Okay? Let's make that look like a 1 and not a prime here. So that's x to the first minus, so then we factored out that whole thing, so it's just a 1. All right, so now we set each factor equal to 0. And so we get... well, x to the first minus 1, x minus 1 equals 0, so x equals 1. So that's going to be a critical point. Now, this one, I'm using the elevator rule to bring that to the denominator because, see, 4 can never equal 0. But when x is 0, the derivative is undefined. So remember, the critical point can be where x is 0, where the derivative is 0, or where the derivative is undefined. So these are your two critical points, 0 and 1. All right, now you do your sign chart. Now this one is slightly different than before because instead of zeros above each of these, I put a u over x equals 0 because it's undefined. Whereas when x is 1, the derivative is 0. Okay, now I do the same thing that I did before where I pick a number in each region and then check to see if it's positive or negative. So let's say if I pick well, let's see. Here, if I pick a number that I can easily do the cube root of, that will make life a little easier. So I'm going to pick like negative 1. So let's see. So the cube root of negative 1 is negative 1 squared is 1 times 4/3 is positive. And then negative 1 minus 1 is negative, so I have a positive times a negative. Whoops. So positive times a negative is negative. All right, now let's pick a number between 0 and 1. That would have to be a fraction. And it's a little tough because I'm kind of wanting something I can do a cube root of easily. So let's say if I did a cube root of 1/8. Okay? The cube root of 1/8 is 1/2. 1/2 squared is 1/4. Dividing by a fourth is the same as multiplying. Well, you know what? It's times a positive. So that's going to be positive. An eighth minus 1 is negative. So I have a positive times a negative, which is also negative. Okay, now the last one, again, I want to pick something I'm going to take a cube root of. So I'm going to pick 1 or 8 or something like that. Let's say 1. Okay, the cube root of 1 is 1. 1 squared is 1. 4/3 divided by 1 is positive. Oh, no, I can't pick 1. That's the border point. That's the critical point. So I'll pick 8. Sorry. The cube root of 8 is 2. 2 squared is 4. 4/3 divided by 4 is positive. 4 minus 3 is positive. Positive times a positive is positive. Okay? Notice that I try not to get bogged down in the computations there. I mean, you can use your calculator if you want, but if you can pick things that you can do in your head, it'll really make things go a lot easier. Okay? So now where this is decreasing from negative infinity to 0 and 0 to 1, increasing from 1 to infinity. Okay? Oh, let's see, that's just math over there. All right? Now, where it changes, that's where you have a relative extrema. So there's no extrema here because this derivative didn't change sign. Okay? Here, where the derivative went negative, 0, and positive. So if the derivative is going down, the function is going down, 0, and then up, then you're going to have a local minimum at x equals 1. Okay? And so if it asks where is the, let's see, does yours ask where? So to do the intervals where the function is increasing and decreasing, so I'm going to say, so it's in decreasing. So that would be from negative infinity to 0. and then from 0 to 1. And then the function is increasing. Whoops. So then the function is increasing where the derivative is positive, and so that would be from 1 to infinity. And so then where the derivative changes signs, that's where you're going to look for your local max or mins. So if the derivative goes negative, 0, positive, then that's a min. If the derivative goes positive, 0, negative, that's a local max. Okay? All right, so see if you can do practice 2. All right, so Denon, when you've got the critical points.
It's 0 and 1.
0 and 1. Let's see if that's right. 0 and 1. Good job. Any questions up to that point? Okay, so Skylar, when you've got the intervals where the function is increasing and decreasing.
Mr. Strong,
Yes.
really fast, how do you get that x minus 1 out?
Okay, so what you're trying to do is factor this. Okay? And so you factor out the 3 halves, and then there's an x. And to figure out what this power is, it's the lowest one of these two. So negative 1/2. All right? And then when you figure out what the power is here, you subtract 1/2 minus a negative 1/2. That's the same thing as 1/2 plus a half, which is 1. Minus, and then you factor out this whole thing, so it's just 1. And so then when you set that equal to 0, you get 1. Does that help?
Yeah, thank you.
You bet. I know now, and I know, like I was saying, I know you haven't done a lot of factoring with rational exponents, so that's probably where the practice needs on this one.
It's increasing from 1 to infinity, but I don't know the decreasing.
Okay, increasing from 1 to infinity, decreasing from 0 to 1. All right. So if it's increasing from 1 to infinity, because when you plug that in, whoops, you got positive here, and from 0 to 1. Okay, so to plug in a value from 0 to 1, you want something where you can take the square root. So I would say like 1/4. So the square root of 1/4 is a half. Okay, so 3/2, 3 divided by 2 times 1/4. This is going to be positive. And then a fourth minus 1 is negative. So a positive times a negative, that's going to be negative. The tricky thing here is when you try to plug in a negative, then what happens when you try to take the square root of it?
Doesn't work.
It's not defined. So the function is not defined there. It's undefined. So that's why you just say, okay, where the derivative is positive, the function is increasing from 1 to infinity, decreasing from 0 to 1. That's it. There's nothing going on over here. Okay? Now, so the sign changes from the derivative from negative to positive. So what does that mean? Do you have a max or a min here? Anybody?
It would be a minimum.
It would be a minimum. So local min at x equals 1. Okay, so what I'd like you to do is, I'm just curious about if you can solve that trig equation in practice 3. All right, so I want you to see how far you can go in practice 3 before class tomorrow. And if you can't get far at all, that's fine. But just try it and see what you can do. Okay? And then we'll pick it up from there tomorrow. Okay? So we'll see you.